Hey everybody, welcome to Chapter 4, Section 5, Proving Triangles Congruent with Angle Side Angle and Angle Angle Side. So in these notes I'm going to do a couple of proofs that basically demonstrate these congruence properties. So the first one I'll start with is the angle side angle congruence postulate. And so the angle side angle postulate is pretty much exactly how it appears. You have a side that is known to be congruent in between two angles that are known to be congruent. So if these two angles are marked as congruent, you don't want to have this side or this side marked as congruent in order to be considered angle side angle. See, it goes angle side angle. So yeah, I guess that's pretty much all there is to say about angle side angle. So with that being said, I will start example 1. Given QS bisects angle PQR and angle PSQ is congruent to angle RSQ, prove that segment PS is congruent to segment RS. So anytime you're doing proofs and you are unsure as to what to write, well then consider this. Always start with what's given and then build from there. And then how you build from there is you got to think about where you're trying to prove. I'm trying to prove that side PS is congruent to side RS, but more specifically, I'm trying to prove that this is congruent using the side angle side congruency postulate. So ultimately, I need to prove that two angles are congruent to one another, and then a side in between those two angles is congruent to the other side, right? So let's look at what's given. So QS bisects PQR, okay, great. And then angle PSQ is congruent to angle RSQ. So right off the bat, we already know that one of the angles is congruent to itself, or the other one, not itself. So that's what I chose to write down first. I chose to work with that given statement first. It doesn't really matter which given statement you work with first, but this is the one I chose to do. So I'm going to go over here onto my proof or reason side and just write the word given. So if we're thinking about the angle side angle congruency postulate, angle side angle would work for a congruency postulate. I could also go angle this side, that angle. But this one's easier to work with. Work with this angle, prove this side's congruent, then this angle's congruent. This one's definitely easier because why? They're sharing this line. Triangle PSQ is sharing the line of SQ with triangle RSQ, right? So all you have to say is line SQ or QS, however you want to say it, is congruent to itself. That one is definitely to itself because QS is in both triangles. So I wrote QS is congruent to QS. Anytime you say something is congruent to itself, that is the reflexive property. So now we've established that, hey, there's an angle that's congruent. There's a side that's congruent. Now I just need to prove that this angle up here is congruent. Well, we'll use that other given statement of QS is bisecting angle PQR next. So I'm going to put that right underneath here. So here I have QS bisects angle PQR, and that's given. And what does that help prove? Well, remember, anytime you bisect an angle, you are essentially cutting it in half. So that means this little angle segment is going to be congruent to this angle segment because it cut in half the angle of PQR. Okay, so we now know that angle PQS is congruent to angle RQS because of the definition of an angle bisector. So you can see that here I wrote definition of an angle bisector to kind of lead you into this anyway. So yeah, we'll just say angle PQS is congruent to angle RQS. Okay, so now that I have that down, we're essentially done, right? We gotta just wrap up this proof because we've proven that this angle, this side, and this angle are congruent to one another. So we've proven, we have enough information, I should say, to prove that these two triangles are congruent. So I'll call this triangle PQS, and I'll call this triangle RQS, and we'll say those are congruent because of the angle side angle congruency postulate. And so now that that's written down, we'll we'll turn our attention to this. Well, what you're trying to prove always goes in the final line of your statement box. So I have PS is congruent to RS. How do I know that for sure? Well, once you've established that two triangles are congruent to each other, think back to what we learned in Chapter 4, Section 3 about corresponding parts of triangles. Because it says that corresponding parts of congruent triangles are congruent. So all you need to do is just abbreviate that for CPCTC, and that'll be your reason. Okay, so once again, CPCTC stands for corresponding parts of congruent triangles are congruent. So you'll pretty much use that CPCTC after you've proven that these two triangles are congruent, and you're trying to answer a follow-up question of, are these two angles congruent, or are these two, in this case, are these two line segments congruent? So I hope that makes sense. So yeah, that problem's done. So let's turn our attention to this. I'm going to do an example proving or demonstrating the angle-angle side congruency postulate. So the angle-angle side has a like a not I was about to say non-connected, but not in between the two angles that are given. So if these two angles are given as congruent, then you can say that you can use this for the side, or you can use this for the side. But if you use this one for the side, you'd be talking about the previous one that we just covered of angle, side, angle. So this one is angle, angle, side. I guess you could read it as side, angle, angle. Just, it's always written down as angle, angle, side. So just if you see that, just write down angle, angle, side rather than side, angle, angle. Okay, so I wrote, given that angle DAC is congruent to angle BEC and DC is congruent to BC, prove that triangle ACD is congruent to triangle ECB. So let's start with what's given. And since we're trying to do angle side congruency, I'm going to work with this part first for my given statement, and I'll use this at the end after I've proven two angles are congruent to each other. The order doesn't really matter, but I just feel like it flows better that way, since you can read it like, okay, this angle's congruent, this angle's congruent, this side's congruent. So yeah, of course it's angle side. So if it's kind of mixed up, then I feel like it kind of confuses people more. So yeah, long story short, I'm going to write this, angle DAC is congruent to angle BEC in this first line. Okay, so with that given, what we've established is these angles of the triangles are congruent. And this picture is kind of confusing. We're looking at triangle ADC here and triangle BEC. So anytime you have these overlapping kind of triangles, it might help if you just kind of like separate them and draw them out yourself. So that's what I've done here. I just kind of crudely drew the triangles because this one's overlapping and it's like flipped. So we've established that these top angles are congruent right now. So next, let's prove that another angle is congruent, okay? Because it's angle side. So we could try and prove that angle D is congruent to angle B, but the easiest thing to prove congruent is that angle C is congruent to angle C, because, I mean, it is the same letter, but look at the original picture. They are overlapping and they are sharing this angle C. So if they're sharing it, just like they were sharing this leg of QS in the first example, well, if they're sharing an angle, then that's also congruent because of the reflexive property. So that's, officially what I wrote down. And so now we have two angles are congruent to each other. And so next, let's prove that a side is congruent. So I turn my attention to what was given next, and that's side DC is congruent to side BC. So we just need to write the word given right there. And so if you look at the picture and you kind of update it, we know that angle C is congruent and DC is congruent to BC. I now know that these two triangles are congruent because of the angle side congruence postulate. And so again, for your final line of your two-column proof, you want to put where you're trying to prove in the statement, and then how you definitely know that's true. Well, we definitely know that's true because of the angle side congruence postulate. So I saw this picture in our textbook, and I thought it was pretty good. This pretty much wraps up the last two sections. You have an example of side, 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 angle, and angle, side, all on one little table. So feel free to refer to that as needed. But that's going to wrap it up for these notes. So thank you for watching, and goodbye.